Hello, this is Michael Delvaux. Today we're going to look at a rock outcrop exposed by a road cut on the island of Borneo. As I zoom in to the northern part of the island, you can see where I'm actually located, where that blue dot is. Now, this is the outcrop and its location. We can see that it's a sedimentary rock and the bedding is dipping very steeply to the left. So let's walk the section from right to left. The first thing we notice is that it's very thinly bedded. These beds are fairly parallel, but in places do seem to have an angular relationship to other beds. But it's a fairly subtle angular relationship. And I'm not seeing any sedimentary structures like ripple marks that jump out at me. So let's go back to the beginning. And here I can see two shale units, the rest being a fine-grained sandstone. The right-hand side of this picture is fairly weathered more than the left-hand side. But on both sides, I see a cyclic pattern. There are thin layers of light-colored, fine-grained sand, followed by thin layers of dark material. And here we can see just a small localized area of small pebbles and perhaps a channel cut right here. But there's also bed thickening going on in this direction here and in this direction here. Taking a closer look, the pebbles aren't really pebbles, but rather pebble-sized clay lags. Then it looks like the sediments on the left drape this area of clay lags. And the sediments on the right are maybe perturbed and truncated by these clay lags. And the channel cut or scour truncates the sediments on the right. But the scour fill sediments have an angular relationship to the unscoured. They still maintain that light and dark cyclical depositional characteristic. So it is unclear to me why the deposition within the scour is at an angle like that. But this small area tends to indicate that down is towards the right. So let's move further left along the section. Here I see some pebble-sized clay lags, and it looks like it's kind of in the channel bottom that would indicate the bottom was to the left. And what is this to the left of my finger? That looks possibly like some kind of a burrow or something. It's an unusual burrow in that it cuts through the individual layers at about a 45-degree angle. Then there are these oval-shaped structures that I have no idea what they are, whether they're depositional or post-depositional. Then this looks like another channel cut, possibly indicating the bottom is to the right. The problem is there is no ripple marks to kind of determine which direction the sediment was coming from. Then these are clay lags on what I'm guessing is a top surface. Now these are some unusual patterns. My guess is that these are the result of small organisms feeding throughout the sediment. Then there's these markings, which look like tracks, except that they go through the different layers. And more unusual markings going through the different layers. and more unusual markings. Now this area has a few nice vertical burrows. So if we look at one of these burrows very closely, it looks like it has an opening here, and the bottom of the burrow terminated here, giving us the indication that, yes, the downward direction is to the right. Okay, structurally, we already had determined that the bedding was dipping steeply to the left. Now, if we look closely, we can see that there are fault planes both here and here. These fault planes are parallel to the bedding, and I'll show the relative motion along these faults here. Another fault plane is here. This is a close-up of that fault plane and from a different angle here. Okay, so let's go back and let's see if we can try and figure out what happened here. In general, we had sediment deposition followed by lithification into the rock formation that we see here, followed by some kind of uplift to bring the bedding, which was horizontal, to a near vertical state, and lastly, followed by the faulting that we saw at the just previously. So, what was the depositional environment? Well, the sand is fine-grained throughout. There is a cyclical pattern of light and dark, thin bedding or laminations. The dark laminations are composed of probably organic carbon and possibly a smaller grain size. This indicates that it was a rather low energy deposition with slow currents, with a lot of fluctuation, and with a large sediment supply. So I propose that this was a tidal delta, and let me explain why. This is a sketch from Sheep Island, North Carolina. The ocean is to the right, and the basin or the lagoon is to the left. The ocean side is high energy with large waves. So this would result in fine-grained sands being kept in suspension and brought out to sea. Only coarse-grained sands would be deposited in this environment. Now, the basin or lagoonal environment, on the other hand, is very quiet. To the left of the lagoon is the main continent. This sketch shows a lot of sub-environments within the lagoon. These environments are exposed to incoming and outgoing tides. And over time, these islands and these sub-environments move. So in the sedimentary record, you would expect to see fine-grained sands, channel cuts, areas of stagnation where you might get algae or plant growth, and burrowing organisms. These sub-environments would be ever-changing and stacking up on one another. So I propose that our outcrop was deposited on the basin side of a tidal delta. Now, as a caveat, I have not read any literature about the geology on this side of the island. So this interpretation is entirely mine, and I have not related it to other outcrops. So I take no responsibility for what someone might do with this interpretation. I also have no way of telling the age of this outcrop. And here are some photos taken by an acquaintance of mine from the coast of Australia. This is the high-energy beach with the lagoon on the left. Here we are looking at the lagoon and the beach and the tidal delta in the background. Various low-energy environments in the lagoon. This is Michael Delvaux in Borneo. Thanks for watching.